What's happening, dogs? Mr. Allen here with some evaluation of trig functions using our double angle formulas. We got if sine of theta is equal to 3 over 5, and theta is between 0 and pi over 2, so first quadrant, find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. All right. So these start out the same way we normally would have with these types of problems, and if I ask you to find like cosine and tangent of theta, I would draw my triangle in the appropriate quadrant. Let's start with that, okay? So I have draw out my quadrants here. We said it's in the first quadrant, right? Draw a little triangle. This is my theta right here. Right triangle. Opposite is 3. Hypotenuse is 5. This is why I favor with my triangles rather than unit circle, because I got to draw these triangles up for a lot of different problems anyways, right? Now, my man Pythag will tell me that this thing is 4 right here. It's a 3, 4, 5 triangle. Knowing your triples is super helpful for these style problems, right? Because we got 5, 12, 13, 8, 15, 17, and 7, 24, 25. They all come up in these types of problems, okay? They favor the Pythagorean triples. So remember those. It'll save you some time. So now I got to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Well, if you look at our formulas that I have written up here, it all involves evaluating at theta. So how about this? Let's write out right now sine of theta. We already know is 3/5, right? So 3 over 5. Cosine of theta, that would be my adjacent over my hypotenuse, so 4 over 5. And tangent of theta would be opposite over adjacent, so 3/4, 3 over 4. And now I can basically just like plug and chug this stuff in, right? Just plug it into the appropriate formula. So let's write down our sine of 2 theta, double angle formula for that one. So we got sine of 2 theta is equal to 2, almost forgot my s, sine. It's a great S. And then we got cosine of theta. Okay. So we got 2 sine theta, cosine theta. Well, sine theta is just 3 over 5. Cosine is 4 over 5. Let's plug those fractions in. 2, then we got 3 over 5, 4 over 5. Can you work with hopefully, I know they're a little bit scary. I know. But it'll be okay. Let's throw this 2 over 1. Let's put some training wheels on here. And I got myself 2 times 3 times 4. That's going to be 24 over 5 times 5 is 25. Boom. Bingo. We got sine of 2 theta. There we go. Next one. Cosine. Cosine of 2 theta. Well, I got to use my cosine formula right here. So it's cosine squared minus sine squared. I'll write that down. We got cosine of 2 theta equals cosine squared theta minus sine squared theta. Now, cool thing about the cosine double angle formula is you can actually rewrite this in a couple different ways using your Pythagorean identities. This one's fine for this particular problem, so let's just leave it as is, all right? So we got cosine squared theta. Well, cosine of theta we know is 4 over 5. And if I square that, I'll just write it out here, 4 over 5. We're going to have it squared. And then we got sine, we know is 3 over 5. See why it's helpful to write these things out here? Super helpful. Now I can just square this stuff, right? And when I square a fraction, we got to square the numerator and the denominator. So I get 16 over 25 minus, and then I get 9 over 25. We have like denominators. Good to go there. We don't have to get common denominators, which is lovely. So it's just 16 minus 9, which is 7 over 25. Nice. It's interesting. 24 over 25, 7 over 25, those are part of like our Pythagorean triples. Wonder if there's any connection. We'll explore that another time. All right. Tangent time, right? Tangent of 2 theta. So I'm going to write down my tangent of 2 theta formula. I find that helpful, to write that stuff out first. Then I can just plug things in. It takes some of the thinking out of it, I guess, which is kind of lovely when you just want to just roll with it, man. All right. Tangent squared of theta. So tangent of theta is 3/4. So we're going to be rolling with 3/4 here quite a bit. I'm actually going to come over here with it. We got 2, and we said 3/4, right? So 3/4. Then we got 1 minus 3/4 squared. Dang it. 3/4 squared. Okay. So 2 times 3/4, that's going to be, we got 2 times 3 is 6 over 4. Actually, why don't we just reduce that? That'll be 3 over 2. Right? 2, 4, 2 divided by 4, that will reduce down to a 2. You get 3 over 2. 1 minus, we got 3 squared is 9 over 4 squared is 16. So now I got to get a like denominator here, okay? In my denominator, we got complex fraction. So I want to write my denominator here as 1 fraction. Well, we can do 16 over 16. So we got 3 over 2 still. Got to get kind of small here so we don't run out. And then we have 16 over 16 minus 9 over 16. Let's come back up here. Whoop. Equals. So here I got 7 over 16. I'm going to do one more big old fraction here, and then we're going to rewrite some stuff. We got 7 over 16. I'm currently dividing by a fraction, which I can rewrite with multiplication. This is the official way of doing it. That's the universal sign for multiply by the reciprocal, right? That's not official. I'm just kidding. But we use it all the time at my school, and we're the best. So reciprocal of that is going to be 16 over 7. So I get, let's reduce that. That's an 8 right there. So 3 times 8 is 24. 7. Boom. Diggity. Done. So the challenging part here is that we are dealing with a lot of fractions. When we get beyond a 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, the numbers do get a little bit large. So sometimes it's nice to bust out a calculator, but these are non-calculator problems for most tests. So be on the lookout for that. But there we go, guys. 3 different ones there. It's pretty awesome. Know your formulas, unless your teachers give them to you. But, there we go. All right. See ya.